It's time for the math easy solution. We're going to discuss another video on integrals and volumes, and now look at example 9 of the example series. I'll go over this example, which states a wedge is cut out of a circular cylinder of radius 4 by two planes. One plane is perpendicular to the axis of the cylinder, and the other one intersects the first plane at an angle of 30 degrees along the diameter of the cylinder. And then we have to find the volume of this wedge. So if we were to draw this out, so if we just draw a cylinder like this, so here's a cylinder. So if we were to draw the two planes or to see where they cut, this one is perpendicular to the axis of the cylinder. We'll say that's the axis. As you can see, it's circular or about this origin there. So now, if we perpendicular to it, it would look somewhere. Let's just pick a random spot here. So there is a spot perpendicular, and this is a circular one. Radius is 4. So now we have something like this. And now the other one intersects the first at an angle of 30 degrees along the diameter of the cylinder. So it's around about this diameter. So if that's the diameter, we'll call this the origin. So now this is going to be crossing it at an angle of 30 degrees. So it's going to look something like this. And then if you draw on a 3D map, so it looks something like this, where that is 30 degrees. So now we have to find out this volume of this wedge that's created from these two planes. So now, like always, we've got to draw first of all our x and y axis. This one, I'll just call this axis z. I'll start at the origin here, and my calculus book actually uses this coming towards us here as the x-axis, because it follows along this shape right here, just along the diameter, so that when we have a cross section, it will have the triangular cross section, which will make the calculation easier. I'll get to that in a bit. And the y-axis, we will draw it here. So this would be the y-axis right there. So now, like always, we have to find out where the cross section, just a general cross section, is at any point. So let's say at x here, we're going to have a cross section that's going to be something like this. I'll just draw this across, etc., like that, and it's going to be all the way up top, and now it's going to be like that. And as you can see, it is just a triangle, where so from here to here is x, so we have this cross section, a general one, and it's a distance here of y right there. And this one again is 30 degrees. So this one right here is 30 degrees. It's every single triangle is going to be 30 degrees. In the angle is always going to be 30 degrees. And now this will be basically our a of x right here. That is our general cross-sectional area. So now if I just drag it down just to see it by itself, it's going to look something like this, where this is, again, it's a right angle, this triangle. It's going to be a right angle. There is y. It's going to be 30 degrees. And now we have to find out this area of this. To do that, well, let's call this side right here, we'll call it just z. So we know that the area of a triangle, this one is going to be equal to, this has the area of a triangle, so this is going to be base times height divided by 2. And in this case, it will just be y times z divided by 2. So now we got to find out this z value. So now we have to look at our our exact trig ratios. So if I were to go back here, exact trig ratios, you can learn more about this in my earlier videos. If you have, for example, just a triangle like this, if the sides are 1, 1, this would be 45 degrees. This would be square root 2. Just use Pythagoras for there. But then when we have it in this case 30 degrees, it's going to be a thinner one like that. And then this is going to be 1. Actually, no, this is going to be this is going to be 1. This is going to be square root 3, and that is our 2. and the other exact one is the 60 degrees, but we'll just stick with this one right here. So now we have this right here, we have this ratio, so Z right here, this also equals to, equals to tan, or opposite over adjacent, so this is going to be opposite over adjacent of 30 degrees, times it by y, because we know that tan 30 degrees equals to, well, opposite over adjacent. This equals to z over y. Now we move the y over this side, so there is our z value. Tan of 30 using the exact trig ratio. Here, tan 30 degrees equals to, well, opposite over adjacent, 1 over square root 3. So then this is going to be equal to y over square root 3. Yeah, so our area is here. Now we can simplify it further, put the z inside, which is y over square root 3. So now we have y squared divided by 2 and divided by square root 3. So that's y squared. But now we need to write it in terms of x. To do that, we have to take this shape and basically write y as a function of x. So we will continue on here. Yeah, so now if we were to look at the shape, looking at downwards onto it to see the x and y plane, will look something like this. This radius right here is 4 equals to r, and this is just a half circle, and we know that the equation of this, well, we know that the equation of a circle is just equal to x squared plus y squared equals to r squared. In this case, it will be 4 squared, which equals to 16. So we could rearrange it. Y will equal to plus or minus, but in this case is the positive side. So we'll just circle the plus of square root of 16 minus this x squared. So we're just rearranging it. So that is what y is. So I'll just write that down right here. Y equals to square root 16 minus x squared. So now we could plug this into our area function. So we get a of x equals 2 y squared over 2 times square root 3, which equals 2. Yeah, equals 2. Well, we just plug in square root 16 minus x squared, but there's a squared here, so the square root cancel. So we'll just have 16 minus x squared divided by 2 over square root 3. So now we have basically our area function. And once again, our delta x is just going to be the length of this. So just make it look like a 3D wedge right there. That's going to be our delta x, is this distance right there. So now when we have it infinitely small, it will be dx in our volume integral. So now we do the volume is going to equal to from -4 to +4, because again this is a circle. So this point will be -4. And that here will be 4, or x equals 4. So same thing here, -4 all the way to 4. So we integrate from there to there of ax times dx. And now this equals to, also because, well, when we look at this, this is just symmetrical about the origin, about the this y-axis right here. Yeah, it's symmetrical about it. So we could just basically solve for from 0 to 4 and just multiplied by 2. So the volume will be the same thing because it's the same on both sides. So we'll go 2 times 0 to 4 of ax, or ax dx. So this just simplifies the calculations a lot. And now this would be 2 times 0 to 4. Now we just plug in our a of x, our cross-section area. So 16 minus x squared, 2, and then the times square root 3. Now these 2's cancel. Yeah, so the 2's cancel. Yeah, we'll just cancel this out. And now when we integrate this, and we could also take this square root 3 out of there, or 1 divided by square root 3 out. And now we integrate this top here, 16 minus x squared. That'll be 16x. X squared is just x cubed over 3. And now it's from 0 to 4. So now we plug in 4, and we plug in 0, it just cancels and becomes 0. So that's why it's simplified instead of having to deal with this -4. So now when we plug this in, this will be 1 divided by square root 3. 4 times 16, well 2 times 16 is 32, times that again by 2, that's 64, minus, now plug this in here, so 4 times 4 is 16, times 4, 64, divided by 3. So now you could just put in a calculator or just try to solve in your head. I'll just factor out the 64 out of there. So 64 over square root 3, 1 minus 1 over 3. So now this is just 2/3. Yeah, so this is, or you can consider as 3 over 3 minus 1 over 3. That just equals to 64 times 2, yeah, thirds, and there's a square root of 3 right there. And again, 2 times 64, that's just 128. Divided by 3, square root 3. And so there is our volume of the wedge between the cylinder. And yeah, so anyways, that is all for today. Hopefully you'll learn from this video, and like always, you could download these exact notes in the link below. And thanks for watching, and stay tuned for another math easy solution.